So everything we've been doing is solving polynomials. And we have done that by using P's and Q's to get a possible zero. Finding one that works, and how do we know when a zero works?
It equals 0.
Yep, you plug it in, it equals 0. And then once we find that first zero that works, what did we do? Synthetic division. Okay, but I want to remind you, that strategy can be time consuming. And just because we have that doesn't mean that our old stuff will never work. So don't forget, we can always check to see if any of our old factoring strategies are an option. Just because we have P's and Q's doesn't mean that's the only way we can solve these problems. So if I gave you this problem, x cubed plus 3x squared minus 4x minus 12. I can do P's and Q's. Do I have to here?
No, you just take out x squared and 4. Or actually,
Couldn't you do grouping?
Yeah. Yeah, so we're going to do grouping and factory to those. One thing to remember with grouping, so we always put the first two in parentheses and the last two in parentheses. Can I do it like this?
No.
Yeah, you gotta distribute
Yeah,
that
there you
negative.
Okay. This is plus negative 4, and you always put your parenthesis after a positive sign. So don't add a parenthesis after a subtraction, that will change the meaning of the problem. You have to write it like this.
Oh, and you can't, I always have put the parenthesis over the plus or minus. But then it looks like
It's multiplied.
multiplied, and I just,
Yeah.
you know, and it
As
wasn't.
long as you knew it wasn't, you're fine. But so the first one, you could take out x squared. That leaves us with x plus 3. What can we take out of the second parenthesis? X plus 3. And remember, with grouping, the goal is for these parentheses to match, which they do. So then we could take that out. If I take out the x plus 3, what do we have left?
X squared minus 4.
And then how do we factor x squared minus 4?
Plus 2 x minus 2.
So P's and Q's would have worked, but this is definitely faster. I asked you to solve this. So what are my solutions?
-3, -2, and 2.
What's another word for those numbers? Zeros, yep.
Or roots.
Yep, zeros, roots, x-intercepts, all of those. Okay, so if I wanted to graph it, I'm kind of thinking back, what was the degree of this thing? What is my end behavior? Okay, we already found our zeros. They're all multiplicity of 1, so will it go through or bounce?
Through.
If I asked you for the y-intercept, how do we find that? If I put in 0 for all of my x's. Okay. So, my zeros, where we hit the x-axis. The graph starts down here and I'm going through my zeros. Go through, come back and hit this one, go through, come back and hit this one, go through, and it keeps going and matches my behavior. Please make sure when you're drawing those that it does look curved. It's not a zigzag. And make sure it's a function at the end. It should pass the vertical line test. Is that okay? The graphing piece is kind of a review. We've been doing that. If I have this graph, I could ask you a couple other questions. We did similar ones when we were talking about parabolas, but bless you. I could use it for all polynomials. if I want to know when this was greater than 0, what does greater than 0 mean?
Above the x-axis.
So it's above here and here. You write that as intervals for the x's. It's not equal to, so we use parentheses. So this one is between -2 union, and this one is from 2 to infinity. And if I asked you where it was less than is below. So these sections of our graph were below the axis. So you give me the intervals for the x. So it's coming from -infinity, stopping at -3, union. This one starts at -2 and goes to +2. Is that okay? So we got our zeros just by factoring techniques, and we are still reviewing our graphing, and I asked some inequality questions. Let's do this question. If I want to solve this one by factoring. Is there a greatest common factor? No. Do I have enough terms to do grouping? No. So, any other ideas before I try P's and Q's?
We'll just do the,
It's like a quadratic, isn't it?
You just have to have x squared instead of just x.
You have 4 x's that would break into x squared. And since this middle term is an x squared, that'll work. When in doubt, P's and Q's will work. Okay, it's just if there's a faster option, we want to make sure we're not forgetting about those. So what would multiply to -40 and add to -6?
That would be 10 and 4.
Do either of those factor further? No. So if I want to solve it, set them equal to 0. If we add over the 10, get rid of a square with square root with that plus and minus. We get plus and minus the square root of 10. Here x squared would equal -4 square root plus or minus. What's the square root of -4?
so if you did it the P over Q way, would you not have radicals?
Yeah, so when you tried your possible zeros, none of those were going to work because there were no rational zeros on this one.
So then what would you do?
If you couldn't factor it using anything, you couldn't do the P's and Q's. You're out of options at this point. So I wouldn't give you one where there were no rational zeros unless it could be done by factoring.
But so when you do the P's and Q's, none of them would work.
Mm-hmm.
And then I would probably make that as impossible again.
Yeah. So if I wanted to graph it, we would need to know our degree. What's the degree here? 4. So what's my end behavior? My zeros were these that we just found. Would I go through or bounce? Y-intercept, if you put in 0 for x, we get
-40.
right. so my 0, square root of 10, we could certainly approximate that, it's a little past 3. Negative square root of 10 would be a little past negative 3. Can you graph plus and minus 2i? No, we don't graph the imaginary zeros. So my polynomial, it starts up here, because my behavior is up. At our 0, we said we would go through. Hit our y-intercept negative 40, hit our next 0, go through, and look something like this. All right, take a second and answer questions C and D by looking at this. Okay, so greater than 0 is when it's positive, so that would be above the axis, so the ends in this case. So negative infinity to negative square root of 10, union positive square root of 10 to infinity. Less than 0 is below, so that would be here. So that's from negative radical 10 to positive radical 10. Okay, some of us had a little trouble with that, so let's try another one. Let's do this problem. If I asked you to solve this by factoring, could I even do P's and Q's on this? P comes from the constant. Is there a constant? No. What would you do here? Okay, and then that leaves me x squared minus x minus 6. And x squared minus x minus 6 would factor into? Okay. So my solutions, or my zeros, what would make x squared equal 0? But since it was squared, that's multiplicity 2. What makes x minus 3 equal 0? And x plus 2? Remember, your degree tells you how many zeros there are. This was a degree of 4, so we got 4 zeros. 0 twice, 3 and negative 2. I'm keep putting the graphing on here just because it's good for us to review all this, especially with the test coming up. On the test, just like on your quiz, I would step you through all the things I needed you to find. What's our degree on this one?
4.
So that means my end behavior is? The zeros we already listed, bounce or through. So what's going to happen at 0? Bounce, because it has an even multiplicity. And 3 and negative 2 will go through because their multiplicity is 1 and 1 is odd. What's the y-intercept if you plug in 0 for your x's? 0. So I hit my x-axis at 0, 3, and negative 2. My end behavior should start up here and end up here. Okay, so if I'm drawing my graph curve coming down, if we go through, come back and at 0 it bounces, and at 3 and goes through, so it matches my end behavior. All right, I switched this inequality. I want greater than or equal to 0. So greater than is above. Actually, let's not do the equal to here. I'll explain why in a second. But if I just wanted greater than 0, what would that be? I took away my equal to, because then you would have to add the 1 point where it was 0. Less than 0. Okay, that's below, but if it's not equal to, we have to make these two separate things. So from -2 to 0, and then from 0 to 3.
So if you did greater than, would it just be that negative, it'd be -2, union, 0, union, that, okay.
All right, do you guys understand now how to look at the graphs and do less than and greater than? Do we need more practice with those? I just want to do 2 final examples. I won't do the entire graphing. Let's just solve by factoring and make sure we can for 2 more, and then I'll stop for today. So if I ask you to solve this one by factoring, what would you have to do first? Then what would you have to do?
Subtract.
Get everything on one side. So 3x cubed minus 2x squared minus 27x plus 18. And now?
Grouping.
Make sure we change this to plus and negative 27 first. So the first ones we can take out x squared. Second one I can take out -9. Take out my 3x minus 2, that leaves us with x squared minus 9. And so my final factored form would be 3x minus 2, x plus 3, x minus 3. So my solutions, or my zeros, what are they?
2/3, -3 and 2.
So sometimes you have to multiply things out before you can factor it.
When we're graphing, or on the test like the dashboard and factored form, do we have to put it as 3x minus 2, or can we just put 2 over 3?
You would want the 3x minus 2. Technically, if you FOIL it out and you had x minus 2/3, you will get a different polynomial. They have the same zeros, but it won't look the same.
Sometimes that'll just do it because
Yeah.
then it makes it.
Right, it's easier to find your zeros. So if you're just doing your zeros, then absolutely you can leave it that way. Alright, so that one's okay? And if I asked you to graph it and everything, you guys could? Last one. I'm going to put it up here and see if you guys can solve it for me. I want you to solve x to the 4th equals 36x squared. I went back. It's tempting to either want to divide by x squared or square root on both sides, but we're going to lose solutions if we do that. Instead, we need to set it equal to 0. Then what can we take out? Okay, and x squared minus 36, what does that factor into? So our solutions, or our zeros, are what? so we got the 4 answers we predicted. Alright.
But if it doesn't have to have 4, correct?
Right. You will have 4, but they don't all have to be real numbers, or you might have something with a multiplicity. But if you added up all of your i's, your imaginary zeros, and your real zeros, it'll always equal your degree. Okay, there is a Math Excel assignment open. You guys have